Okay, so Mr. P in the back row, tell me something you know about the answers to these questions. It's the same on both. Excellent. So therefore, the horizontal asymptote with those two being the same degree, how do you do it if they're the same on both SOBs? Take the ratio of the lead coefficients, y equals 1 over 1, which is 1. Raise your hand if you had that part right. Okay, good. On to the next part. NA in the back row, what do you say about the domain? -5 and 5 will spoil the party because they would go into this equation and make the denominator 0, and therefore anything over 0 does not exist, and therefore my domain looks like that. Raise your hand if you had the same thing as that. Excellent. If you didn't, hopefully you know where you're making your mistake. A lot of people think, oh, another thing it can't be is on the top I factored it, and on the top it's x plus 5 and x plus 1. So why isn't -1 something it can't be? What does -1 do to your function? Makes it equal 0. Is that like breaking a law? No. Putting a 0 on the bottom, that's breaking a law. So we can find the zeros on the top, but those are not necessarily the things that will crash. In fact, they don't crash your function unless there's also one on the bottom. All right. So the next step is the vertical asymptotes in the front row. And so you said x equals 5? Okay. And how come you discriminated against the -5? I don't get why you didn't include the -5 on the vertical asymptotes. Because x equals -5 creates the whole. That's right. And what we were talking about in the back row was factoring the top, and then that gives me the x-intercepts. But be careful, because the x-intercepts are where y is 0. So this has to equal 0. And what makes the equation equal 0? If the top equals 0. But why does -5 cause a problem? And therefore, I should not say it's one of my x-intercepts. Because -5, when you put it in, crashes the function. So it will not touch at -5 because -5 is not a spot on this function. So -1 is an x-intercept, but not a -5 because the -5 wouldn't, even though it's a spot where it would have touched it, there's a hole there. All right, and the last thing is the y-intercepts. The y-intercepts are where, what? X equals 0. And x equals 0 means I put in a 0 here, and here, and here, and all that's left is 5 over -25. And I can reduce that to 1/5, and it's got a negative on the bottom, so it's -1/5. Y is -1/5. That's where it hits the y-axis. So now, if I asked you to sketch it, which I did, how many of you actually have your sketch? Okay, I don't think I must not have made that clear. So everybody, please make a sketch of it. Take this info right here and make a sketch of what this graph must look like. I'll give, yes. This is one of the 3 forms that is acceptable. Another one is set builder notation, and another one is interval notation. You could say interval notation like negative infinity to -5, and then -5 to 5, and then 5 to infinity. You can say it in a lot of ways. All right, you're making a sketch. So I have a hint for you. Put in the asymptotes in both directions. That's going to help a lot. Then, remember how we test on both sides of the asymptote? Just get an idea if it should be really high or really low there. I'll pause for a second while you give that a try. It's not working there. Okay, so first of all, I'm thinking horizontal asymptote runs like the horizon, right? And the horizontal asymptote's at y equals 1. Did you have a dotted line? Oh, that was terrible. Hold on, I'm going to try that again. Did you have a dotted line going across there? Raise your hand if you did. Okay, good. The vertical asymptote, there's one at 5. I'm going over here to 5. And now, I know that generally speaking, these things kind of look like this. Or it could be going the other way. But wait a minute, I went through an asymptote there. There, something like that probably. But how do I know for sure? I check some things. Like, for instance, on both sides of this asymptote, if I find on this side of the asymptote, like over here, that it's really high, well then cool, I know it must be doing one of these kind of deals. All right, so let's try that. So what would be something just on that side, like 4.9? So if I go put 4.9 into this equation, I'm going to use the factored form, x plus 5, x plus 1 over x plus 5 and x minus 5. And if I put in the 4.9 in there, 4.9, 4.9, 4.9, and 4.9, actually, I could basically say it's about 5 in all these areas, because it really won't matter. That's the one where I can't say it's actually 5. So I'm just going to round and say it's about 10 times 6 is 60 over 10 times, ooh, this is the weird one, 10 times negative 0.1. So that becomes a small number. 10 times 0.1 makes it 1, and making it negative makes it negative 1. So that makes negative 60. Oh, so it's really low when I tested 4.9. Did you guys agree that we have something down here then? Okay, so then I'm guessing it's probably like this. One other thing I could do is check my holes. Oh, there's supposed to be a hole at negative 5. That's way over here. At negative 5, did you have an empty spot in your function right there? Okay. And last but not least, we did know the x and the y-intercept. The x-intercept was at negative 1. Okay. The x-intercept is over here at negative 1. Okay, so I guess I need to make my turn a lot earlier. So maybe it's going more like that. And my y-intercept is at negative 1/5. Yeah, my y-intercept needs to be negative 2. So that helped me correct my graph a lot. So pull that out of there, and there we go. Okay, that's a sketch. Now let's talk about word problems. I'm going to give you a situation. I want to see if you can make the right equation for this. I will warn you that your first instinct on this is probably going to be wrong. So be careful. Here's a box. You do not need to draw it perfectly here. I didn't just draw it perfectly there either. So, but I've got a three-dimensional box. And we want the height and the width to be the same. And the length is 3 times longer. My question is, I want a formula for the volume in terms of the length. I know you might be thinking, oh, this is going to be easy. Formula, be careful. For volume, ITO in terms of length. And I'd like you to actually use an L for the length. Volume in terms of L. I'll pause for a second while you give that one a try. If you label your picture wisely, the rest will fall into place. You need a nicely labeled picture, and you need a pure form of the formula to which you then stick in the important things. I'll pause while you give that one a try. All right, here we go. So if you started this way, which is what I probably would have done, call this x, and call this 3x, you're tragically flawed. It's probably not going to work for you because you did your answer in terms of x, which means you did your answer in terms of not the length. You did your answer in terms of the width or the height, and we needed it in terms of the length. So you got to start with the length is L, and therefore what do these have to be? 1/3 L's. All right, so then if you solve it, if you started with like a 3L and an L and an L, then you didn't do it in terms of the length. What is 1L? 1L is the width. See what I mean? So you have to make this a 1L and then adjust from there. Okay, so then final answer, volume is length times width times height, and you get volume is length, which is L, width, which is 1/3 L, and height, which is 1/3 L. There we go. And yes, you could say that's 1/9 L to the third if you wanted to put them all together, but that's not required. Any questions about that one? That was a equation in terms of a variable. All right, next topic is limits. Do you remember the lim of the function as x approaches 0 is infinity? I would like you to sketch me a function that says that. I want a picture. Sorry, I didn't have an infinity there. I want a picture of a function that would do that. Oh, by the way, I also want your function to do this. The limit of the function as x approaches negative infinity needs to be negative infinity. And I hope you're writing on virtual paper so you can erase, because I have one more little requirement. I want f of 0 to be 0. If you follow all of those things, then you've sketched the right function. Actually, make a little picture of it. I'm happy that you, that's actually more advanced to be able to write the function. Just draw me a picture of a function that would do that. Warm, but not hot. Your left end limit was off. Okay, you get that just basically means that the point 0, 0 has to be on the graph? Okay, so I'm going through this spot. This one, that's the left end limit. I can tell because it's x going to negative infinity. So when I go way over here, the function is way down here. So I'm going to start there and then go up like that. That way my right infinity, which is x going to positive infinity, will be positive infinity. All right. So now, let me give you this one. Limit of my function now, this is a different function. As x approaches 0, it's infinity. But I'm going to make your life a little more complicated. I'm going to say x approaching 0 from the x's that are negative will give me a limit of infinity. Whereas the limit of the function as x approaches 0 from the positive numbers will be negative infinity. See if you can sketch that for me. Those are what's called inside limits. I like to call them inside limits anyway, as opposed to the end limits. These are limits as you approach the middle of the function. Pause while you give that a try. Okay, let's see if you did this right. Do you get, we always start with the x. X is approaching 0. The point we're talking about is where x is close to 0. Well, there's two ways to be close to 0. You can come towards 0 from this way, or you can come towards the 0 from over this way. Well, the one that's on the top here, this one, is approaching 0 from the negatives. That means I was over here, and I'm getting closer and closer to 0. And as I do, my y values get close to infinity. So it looked like that. And then this other part, the black part, was where I said x was approaching 0, but from the positives. That means I was getting closer and closer to 0 from over here, and then it forced me to go for a y value of negative infinity, so it went down like that. Raise your hand if you had that one right. Okay. Let's see if you can write one then. So let's say I move this thing over, and it's kind of like this. There's the asymptote line at x equals 4. My question is, can you write the limits for me as x approaches 4? The limit of this function as x approaches 4. And yes, there is a horizontal asymptote, but to be completely honest, it's irrelevant in this case. I'll tell you, it's at 3 just so it makes you feel better. Yes. All right, you should have said the limit of the function as x approaches 4. Do you get that x is approaching 4? As we get closer and closer to 4, either we come from this side, which is where the x's are negative, coming towards 4 from the negatives, we would get forced down there, which is negative infinity. Raise your hand if you had that on your paper. That is awesome. You caught on really fast. The limit of this function as x approaches 4, but from the positives, you do have to put a little plus. You can't do like normal numbers and assume if there's no sign that it means positive. You should put a little plus. Equals positive infinity. Because if we were over here and we were approaching 4, it forces us on this train track and we go up there. Okay, good. Next topic. You have been doing rate problems. So I want to give you a simple rate problem that you can do without a calculator. All right. Let's say I can ride at 1 mile per hour on my unicycle. I'm doing this on purpose because I want to keep the number simple. And who in here has actually ridden a unicycle before? Nobody here? Well, then you're the closest thing, so I'm going to use you. Mr. T rides at 2 miles per hour. The question becomes, if we are doing this ride for life thing, where if we each put in a total of, if we can get a total of 12 miles ridden, that our team will raise enough money to, I don't know, save a plankton family or something. Then the question is, how many hours are we going to have to ride? We're both doing this ride together. Did you write the equation? Write the equation. I'm doing 1 mile per hour. You're doing 2 miles per hour. No, I'm doing 1 mile per hour. You're doing 2 miles per hour. And together we have to ride a total of 12 miles. So remember, these are all about rate plus rate equals rate. That's the little formula I want you to remember. So I'm at 1 mile per hour. He's at 2 miles per 1 hour. And then the tricky part comes in combining them. And it's not super tricky. I know how many miles we need. We need 12, so you put a 12 mile there. And I just don't know how many hours that is. So I put an X here and I can solve it. He said, no big deal. Now, hopefully you know that I just had to multiply everything in this case by X. Super simple because I didn't have any other denominators. You get if I had said that I ride 1 mile in 2 hours, it would have had a 2 down there, and then I would have had to multiply everything by 2 and X. Okay, but the way I said it was this. So now multiply everything by X, and that means there's an X here and an X here and an X here, but that X cancels that X, and now I have 1X plus 2X makes 3X equals 12, and then X must equal 4. Raise your hand if you had that one right. Okay, good. I'm going to do another one like that. Newt catching. It's a new sport. It's going to be in the next Olympics. And I'm able to catch 1 newt in 3 hours. 1 newt in 3 hours. And Jordan is a champion newt catcher. She's able to catch 20 newts in a half an hour. Together, we need to clear a newt-infested area and get rid of 40 newts. How How long will it take us? These are actually really hard problems until you know this little formula trick. And it uses rational functions, and that's what this chapter is all about. And rational means, I gave you this in the first day. A rational number can be blank. Nobody knows what rational means? I'm dying inside a little bit. Yes? Yes! Rational numbers can be written as a fraction. I have a lot of guts wearing that sweatshirt here today. All right. Tell me how to set this thing up. Ah, I see where you're going with this. You said 3 hours or 180 minutes because it depends. Some kids might have done this problem in minutes because we had another answer that was in partial hours. Okay, so how many of you went with 3 hours? How many went with 180 minutes? A couple people. Okay, and I'm fine with either method. All right, and then what's the other newt catching rate? And 1/2 hour. And since I said the numbers in hours, it makes sense that people might have chosen that option. Or of course, 60 minutes. No, not 60 minutes. Half an hour is 30 minutes in this gravity. Isn't that an interesting thought? Time moves differently in different gravities. Anyway, does that mean when you're on the moon that time moves differently for you? Because? But time depends on gravity, and you're in a different gravitational field. You don't think time depends on gravity? Ooh. I think you and the movie Interstellar should get together sometime and see who wins. All right. Anyway, let's move on. Oh, a gigantic shift in gravity. You're just saying that the gravity on the moon isn't different enough. All right. Okay. So the last thing was, how many newts did I have to clear? I think it was 40, right? And I don't know how many minutes, so we put an X there. So if you had to clear a 1/2 and a 3 and an X, it's simple. You just multiply everything by 3 and 1/2 and X times 3 and 1/2 and X times 3 and 1/2 and X. That cancels that. That cancels that. And that cancels that. And now I have 1/2 X plus 3 times 20 is 60X. Shows how my efforts compared to her efforts. And 120 times 1/2, which is 60. And then I'm going to make it 60.5x equals 60, and x equals 60 over 60.5. So it's pretty much just an hour. A smidge, was it a smidge less than an hour? A smidge less than an hour. That it would take to clear the newts. And that makes some sense because if she's doing 20 newts in a half hour, she's effectively doing 40 newts in an hour. And so basically, single-handedly, she can clear that many newts. But I am putzing along at only 1 newt every 3 hours, so I'm not adding very much to this newt clearing effort. All right. So there's rates. What else do you have to know? Last topic is solve. Now remember, in this case, the x-intercepts, also known as the zeros, should be put on a number line right along with the things that are going to crash your function, also known as the vertical asymptotes. All of those things get put on the number line, and then you test around them, and you find out, oh, it works from -1 to 1, or whatever. You find a range of answers. All right, so here we go. You should have factored the top, x plus 1, x plus 2. If you can factor it, you should. And on the bottom, x plus 1 and x minus 1. Does anything cancel? What cancels? What makes it cancel? It makes a what? It makes a hole there. Okay, good. And so now, does that mean it doesn't matter anymore, or is a hole kind of an important spot? That's an important spot. There's a hole at -1, so that is important. Here's -1. There's an empty spot there. It does not work there. There's a couple ways it could not work. It could be an asymptote. It could be a hole. In this case, it's a hole. The other thing that doesn't work down here is x equals 1, +1. That doesn't work. It's not like it just makes the equation 0. It makes it 0 on the bottom. So this is an undefined, and so is this. They're two different kinds of undefineds. One's a hole, one's an asymptote. And the last thing is that -2 could also cause a problem. But it's not really a problem. It just makes it equal 0. If I put a -2 in, the top becomes 0. And then it is all less than or equal to 0. Wait a minute. 0 equals 0 is a good thing. So a -2 isn't like a big deal. It just does cause an important point. It's a z, a 0. And that spot works. How come it works and the other doesn't? Because it just makes the top 0, not the bottom. Now you have to test. Save some time for me. Did anybody test the positive end of things? Okay, and what do we find out? Did it work? Did it work in there or not? Somebody tested something, it worked? It didn't work. How many could verify it did not work? Ooh, a lot of people. Okay, so there must be a no in there. And so that area is out. I'm guessing it probably worked in here then. Yes? Okay. And you never know for sure until you test. Help me out with for the people at home. Did it work in here or not? I'm getting a no in there. And how about at the end of it? All right. I guess everybody'd have to test the intervals themselves by plugging numbers into the original function that are in the intervals to see where it for sure worked or not. That's the last topic I'm going to do for review for today. Have a great day.